Hi all, very good morning. Sure. So sorry we were unable to connect with a couple of days. In between, I had some office extensions, so I was unable to make it. So were you able to practice the project, Shiva? Hi Divya, good morning. Shiva, were you able to practice through the project part? Any difficulties or any things which you are not able to understand through or anything? Yeah, we didn't have sessions from the Monday actually. So we were unable to conduct through because even I was away due to work. I had some long office hours, so we are not able to meet for the last 3 days. So the challenges or difficulties that you faced along while doing the project part. Okay. In the part of our today's session, we are going to look down at what is called as a white paper. Now, what are white papers? Specifically, white papers are the place where we get to know in depth about how the AWS is set up, how AWS is really secure, does the data what we keep is really secure or not, are the clouds really a secure solution or not. Now if we go down and propose a solution to anyone saying that would you like to move your service, would you like to move your applications and services to the cloud, then there will be a lot of questions to those guys, like they would be thinking what should be done in this case, right? Because they are not sure whether cloud is really safe, what will happen if someone gets access to the cloud, or what would happen if the data centers are shut down, or if someone steals all the hard disks or data or hard disks and other things, right? So there would be a lot of questions that people might have in terms before they migrate towards the cloud, and that is where the white papers are specifically the place which actually explains us that how cloud environment is completely set up, whether it is really secure or not. So those things we will be covering up in the part of overview of white papers. So in the first part of the overview of white papers, we are going to look through and see what is called the cloud computing. So cloud computing, as we learned in the first part of our session, is nothing but it is on-demand delivery of IT resources and applications via internet with pay-as-you-go pricing. Divya, are you able to hear it? Okay, so we'll continue towards the white paper. I guess Divya is just having some problem connecting over. Okay, so we were looking at the first part of our white paper where we are going to talk about how is the cloud being set up. So first, understanding what is cloud computing. Cloud computing is basically on-demand delivery of the IT resources and applications via internet with pay-as-you-go pricing. And the cloud computing basically provides a simple way to access servers, storages, databases, and other broad set of application services over the internet. So we can access all the different parts of the services over the internet itself, and then we'll be able to go ahead and configure them. Cloud computing providers like AWS own and maintain the network connected hardware required for these application services. So how are we able to get the services like servers, storage, databases? Basically, Amazon, who is known as AWS in this case, is the one who is going to own and also maintain the complete data center itself, and he is going to purchase all the required hardware, and he is going to connect it to the internet and the network. So we basically go ahead and provision and make use of these services to build a web application or maybe any kind of other applications as well. So we also learned about the different advantages of the cloud. So we learned about the major six advantages, that is trade capital expense for the variable expense, then the benefit from the massive economies of the scale, stop guessing about the capacity, increase speed and agility, stop spending money running and maintaining the data centers, and then we can go global within minutes. Now, when we talk about the security, so someone will surely have a question about what is the security? What is the guarantee that the data that is stored in the AWS is fully safe? Yes, it is safe because they have developed a state-of-art electronic surveillance with the multi-factor access control systems. So just like the way we have multi-factor authentication to get inside an Amazon AWS account, similarly, they have got the data center which has got 24/7 surveillance, electronic surveillance, that is under the CCTVs, and also the people who would like to go inside the specific AWS data center, they also need to have this multi-factor access control systems. So it's not just virtually the MFA is implemented, but it's also physically implemented over the data centers where they have to put through or key through the multi-factor authentications, and then they will be able to get inside the data centers. So they have the staff which is available 24/7 who are going to check through the data center for all the time, and the access is on authorized on the least privileges basis, which means let's say if there is some server or some hard disk that is not working, so specifically the access will be given only to that specific rack where the repair has to be performed, right? So access will also be given at a very least privilege basis, so they'll not have access to all the hard disks, all the data, all the servers, or all the databases which are inside the data centers, right? So it will be given on a very least privileged basis, and only to that specific rack they get the access to which the repair has to be performed. And in terms of the compliance, Amazon basically follows through all the major set of compliances like SOC 1, SOC 2, SOC 3, FISMA, DICAP, FedRAMP, PCI DSS level, ISO 27001, 9001, ITAR, and FIPS. right? So these are the major compliance levels which are actually required for each one or the other cases, and Amazon follows them appropriately in terms of the industry standards. So there are also other standards set up by the HIPAA, Cloud Security Alliance, and the Motion Picture Association of America. Now, talking about the shared security model, so it's not just the part that only Amazon is going to secure the environment, but we as a customer are also required to secure the environment that we are trying to put on the cloud. Now, if you see the diagram which is appearing on the right side of this specific presentation, you'll be able to see that we have AWS at the bottom, and then the customer is at the part of top, which means now here in this case we can clearly understand that whatever global infrastructure, which means the infrastructure which is required in order to spin up a virtual machine, in order to create a database, or in order to create a storage space in the cloud, everything is actually responsibility of AWS. So AWS will just give me infrastructure. All I have to do is, as a customer, I am going to create a bucket where I'm going to store the data. I'm going to create a EC2 instance where I'm going to spin up a web server. I'm going to create a database which could be like MSQL or MySQL or Oracle or some other services as well, right? So all those things, as a customer, I'm going to build it. So the security of the data that I'm going to store in the S3 bucket is completely upon the specific customer itself, right? So that's why we call it a shared security model, where a part of security is basically managed by AWS and the part of security has to be managed by customer in the real-time cases. And then when we talk about the storage decommissioning, so what happens in the storage decommissioning? So let's say a hard disk has been deprecated. Like whatever electronic products we buy today in the market, everything has a life, right? So specifically, let's say you purchased a hard disk which was 10 years back, right? So every hard disk has a specific certain life period, so after which it is just whether it is just like a lucky draw, whether we don't know whether it might run or it might not run, right? So after until 5 years it's going to run very well under the warranty conditions, but after 5 years we would never know if it is going to sustain for a lifetime or it may not. So as per the industry standards, all the storage devices which are available, they need to be destroyed, right? So if they have reached the end of its useful life, AWS follows a procedure which includes the decommissioning process. So how are we going to decommission it? So as per the industry standards which are mentioned in DOD 5220.222-M or NIST 888, so these are the two industry standard techniques where the complete manual has been set up on what should happen when the storage device has reached the end of its useful life. So what we do here, all the decommissioned magnetic storage devices are degaussed and physically destroyed. So if the hard disk has reached the end of its life, they physically destroy it, right? So that what happens in case if that hard disk is being, let's say if I throw it in the garbage and someone finds out that hard disk, and if they try to use any of the tools with the help of which they can recover some old data on that hard disk, it is like customer data getting exposed, right? So from unauthorized individuals. So in order to not happen that, what they do as per the industry standards, they have to completely destroy and degauss the physical physically all the magnetic volumes. In terms of network security, now people might also have a question that if I'm trying to send the data from my computer to the cloud, is there a chance that it might get hacked or something as such? Yes, there are chances, right? So how do we protect it? So Amazon ensures that wherever possible, the connections are always with the HTTPS, that is secure socket layer, which is a cryptographic protocol which is designed to protect against the eavesdropping, tampering, as well as the message forgery. So with the help of this, we will be able to easily ensure that whatever data we are going to send across to the AWS is completely safe and is encrypted while the data is being in transit. So for customer who requires additional layer of security, AWS still offers them to play around with virtual private cloud. So remember, we actually learned about the VPC, where we learned what is a private subnet, what is a public subnet, and inside the private subnet there is no level of access, and how did we control the complete traffic using security group towards the EC2 instances, and at the VPC level we were using the NACL, that is network access control list. And in case if you want to connect the on-premise data centers with the AWS cloud, we also have something called as IPsec VPN, which is basically an encrypted tunnel between the Amazon and your data center. And finally, talking about the AWS and the Amazon, yes, they both are different entities overall. Of course, it's one company, but two different entities, and completely the production network of the AWS is segregated from the Amazon corporate network by set of complex security and the segregation devices. So AWS and Amazon as a two different set of entities are completely separated with a complex set of network security and the segregation devices. And in terms of network monitoring and protection, Amazon also offers the protection from all of these hackings like DDoS attacks, man-in-the-middle attacks, IP spoofing, port scanning, and the packet sniffing by the other tenants. Right? So all these are basically the different types of the ethical hacking attacks, which are basically used in order to trap the data while it is being in the cloud or while the data is being sent from certain computer towards the cloud, right? So in order to stop all those things, Amazon has already taken preventive measures against all of these services like DDoS, MITM, IP spoofing, port scanning, and the packet sniffing. So what does the IP spoofing basically do? So let's learn about a couple of things here. IP spoofing basically is all about like unauthorized port scans by Amazon EC2 customers are violation of the AWS acceptable use policy. Now, if you want to go ahead and make port scanning on the Amazon, it is basically a violation of AWS acceptable use policy. You cannot go ahead and just say that I want to scan the ports on the Amazon AWS cloud. You have to specifically first request a permission in order to conduct the vulnerability scans, and that too you can conduct it only on your own AWS account and not on someone else, right? So IP spoofings or any of the port scans, unauthorized port scans cannot be conducted by anyone else. And even if you want to conduct it, you have to request a special permission much before without violating any of the AWS use acceptable policy, right? So here clearly it says you must request a vulnerability scan in advance. Yeah, yeah, sure.
Yeah, in which scenarios IP spoofing will be causes? I mean, in instance, customer access.
Usually what happens is like when, let's say if I'm not informing Amazon and we're trying to do the port scanning or vulnerability scans, right? So usually at times what happens is every company wants to secure their virtual machines. Okay, so when they want to secure their virtual machines, they conduct some tests to see which all ports are opened or what can be still accessible from outside world over this Amazon EC2 instance, right? So they're trying to conduct the test and find out all those things. So doing that specific test for your machines itself is again a unauthorized part, right? Okay, so you have to first go ahead and say Amazon that I'm going to conduct a test like this on my machine because it is required as a part of my audit purpose. Let's say I'm a financial company like bank or maybe the insurance company. So what happens in this case? I need to ensure that my data is really safe, right? So I am seriously going to conduct a all these kind of tests where whether the instance is really exposed to the outside market, will the people be able to do some penetration testing or do some port scanning from outside, and then they be able to connect inside my machine. So they may try to do all these things from outside the world, but before that itself I would like to conduct one test and see are these things really accessible from outside world or not. So for that we have to first go ahead and inform the Amazon saying that I would like to conduct a vulnerability scan and the port scanning. So, and we should let them know the date and the time. So they would be pre-informed that, okay, it is ourselves who is actually conducting these tests and not the outside world market.
Okay, Pawan. In the real-time scenario, what will be the duration period for port scan? I mean, is it will be done in quarterly basis or yearly basis?
Yeah, usually it is done quarterly basis.
Oh, okay. Thank you, Pawan.
Yeah. And in terms of the credentials, we have all the different types of credentials in the AWS. So specifically, we have dealt with these of the credentials. One of them is password. Now, whenever we want to log in into the AWS account, we require a AWS account which has got user ID and the password. On top of it, we have what is called as MFA, that is multi-factor authentication. So in order to protect our account, what do? We have MFA, that is multi-factor authentication. And then we have the access keys. Remember, whenever we used to log in inside the EC2 instance, there are two ways. One is directly using the key pair, and the second one is using the user ID and the passwords, right? So here we are also using the key pairs to log in into the EC2 instances, because Amazon always believes that if it is a physical key pair, that should be completely with you, and only then you will be able to log in into the system, right? It is something like, let's say if I have logged a specific house and you want to get inside it, right? So let's say if it is like a swipe in swipe out where you just have to swipe my magnetic card and then you can get inside, then if I have lost the card, then anyone with that card will be able to get inside the house, right? It's just like a user ID and the password. So that's not a protection, right? So how can we actually protect it? I should have a physical lock, and once it is a physical lock, there will be only limited set of keys which will be available with the authorized people. Like if I'm the owner of the house, I should completely have that key, right? So that's what we call it as key pair. Key pairs are basically something like lock and the key. So lock is physical lock, and that should be present with you, which means in this case the key pair is a physical file which should be present in your computer in order to log in inside the any of the systems. That's why the key pairs are the most preferred method whenever we are going to launch any of the machines. That's why we see that the user ID passwords are never enabled on any of the EC2 instances. It is always the key pair technology which is adopted. And we have the access keys. So access keys are basically in other way to go ahead and log in into the AWS. So if we want to go ahead and use some software development kits, or if we want to perform some command and operations, we basically use the access keys in this case. And finally, we have the X509 certificates. X509 certificates are more about the security over the video or the audio protocols. Like let's say you have got a website like Netflix, right? So anyone who has purchased a subscription to Netflix will only be able to watch the movies or the videos in it, right? So how does a video specifically play? So whenever I have purchased a subscription, if I go inside and open any of the episode or any of the video that I want to play with, I'll specifically go ahead and click on that, and these X509 certificates are specifically used, which are digitally signed, right? So you are going to get a temporary token for a while using this digitally signed SOAP certificate, which is going to let the backend video know that yes, the person who is trying to access these videos is really a authorized as well as has purchased the subscription. So that place we basically use the X509 certificates. So that was all about the first part of our security processes. So we are going to continue on to this in the next part of our session. Any questions or queries until here? Sure.
No, Pawan. Thank you.
Okay.
Yeah.
Sure.
Thank you,
Thanks
Pawan.
all. Have a great day and we'll meet back again tomorrow.
Sure. Thank you.